So this is our second video covering activity 4.1. I believe in the last video we ended where we were asked to graph this height function. This h of t equals negative 16t squared plus 1,450 feet. And if I recall, this gave us the height of an object at any given time. I think we dropped a baseball off the top of the Sears Tower, and I could tell you the height for any time. So if I said, what is the height after 3 seconds? We'd substitute a 3 in for time, and we would be able to determine the height. Then we were asked to graph this function, so let me open up my calculator. And I believe this is what we arrived at, right? Under y equals, we graphed our function. We set our window to the window they gave us, right? This negative 10 to 10 and negative 50 to 1500. And here was our graph. So they asked some questions. Describe the important features of the graph. Well, looking at this graph, it's symmetric about the y-axis. It looks like it has a y-intercept up top and two x-intercepts, right? It crosses the x-axis on the left and the right side of the parabola. So maybe instead of saying the x-axis, perhaps I should use the words horizontal intercept and vertical intercept, right? So there's one vertical intercept and two horizontal intercepts. So I'll just type that in. The next we're asked, what is the practical domain and range of the height function? Okay, so the actual domain, could be all real numbers. X can be any value, or t in this case can be any value. But thinking about the context of this problem, I'm on top of a building and I drop a ball, right? I'm on the roof of the Sears Tower, I drop a ball. So the ball is not in the air forever. It looks like the ball's in the air for a total of, looks like 9 or 10 seconds, right? Initially the ball's 1,450 feet in the air at time 0. 9 seconds later, or 9.5 seconds later, the ball's on the ground at 0 feet. So when I'm thinking about domain, practical domain would be from 0 to maybe 10 seconds. And a practical range would be maybe 0 feet to 1,450 feet, right? The max height is 1,450 feet. That's when you're on top of the building. And when the ball's on the ground, we'd figure the ground would represent a height of 0. So going back to our question, practical domain, between 0 and 10 seconds. Now, I probably should have used the letter T since they use T and H, and maybe I should have used H instead of Y, again, because they used H to represent vertical and X to represent horizontal, or T to represent horizontal. But I would accept X and Y or T and H for short. Part C says, is the graph of the height function the actual path of the object? So this graph doesn't represent the object path, right? The ball doesn't fall in this curved fashion. This really just tells you the height at any given time. Okay, so the answer is no. The graph only shows the height of the object for any given time. Next, they give us a definition, right? They say the graph of the height function is a parabola. The graph of a parabola is a U-shaped figure that opens up or down. And then I gave you earlier the form of a quadratic equation, y equals ax squared plus bx plus c. Right? I think on the first video I showed this this slide. Right, so a quadratic equation or quadratic function is y equals ax squared plus bx plus c, where c was the vertical intercept. So here's our definition. On page 315, this is a nice little exercise, problem 4. It asks to identify the parts of the quadratic function. Give me the a, the b, and the c. So remember, the number that's in front of the x squared term is a, the number that's in front of the x term is b, and the constant is c. So thinking about this table, what's a, b, and c? So I tried to type this in. Right? In the first function, there's a 3 in front of the x squared term. There is no x and there's no constant, so the b and the c would be considered 0. Right? For the second function, the -2 would be my a. There's no x term, so I wrote 0 for b. And the 3 is my constant, so c is represented by 3. Again, I just want to make sure you're thinking of, what the letter a always comes in front of the x squared. B comes before the x term, and then the c is your constant. The third function, there's a 1 in front of this x squared, right? Think of this as 1x squared, so a is 1. The x term has the number 2 in front of it, so the b would be my 2, and the constant is the -1. And then the last function, we have -1 for my a. The b is 4, and there is no constant, so we use c equals 0. Next, we're asked a few things about the constant term c. So we're going back to the original function, right? The h of t equals -16t squared plus 1,450. And we're asked for the vertical intercept. Well, remember, the c term is our vertical intercept. Right? We have ax squared plus bx plus c. So thinking about our problem, the c term, right? There is no b term, right? So a would be -16. C is 1,450. So the vertical intercept would be at time 0. My height is 1,450 feet. Right? We could always find this by substituting in 0 for t and solving for h. Part B, what's the practical meaning of this vertical intercept? By the way, I'm always going to ask for the practical meaning on any test or quiz. It's great that you can identify the vertical intercept, but I also want you to be able to give me the practical meaning of the vertical intercept. So in this case, it's the initial height of the object is 1,450 feet. Next, we're asked, predict what the graph would look like if we change the 1,450 feet to 800. Well, if you think about that, if the c term is the initial height, and we change the initial height from 1,450 to 800, that's equivalent to lowering the Sears Tower, right? The Sears Tower, that building is 1,450 feet. If we were to change that number to 800, it would make the tower shorter. So I would expect our parabola to look shorter. So let's graph it. Right, here was our old graph. And I'm simply going to keep both graphs in the same window. So we still have our -16x squared. The only difference is now we're going to say plus 800. And when I press graph, you'll notice it's a similar parabola, but it's shorter. Right? That's 1450 up top, and down here this is the y-intercept, or the vertical intercept, happens at 800. So the parabola would decrease in height, and we verified that. This completes our video. Please look for video number 3 for activity 4.1. Thank you.